Okay, so in this lesson, we're going to go over inverse functions, and we're going to eventually learn how to determine whether a function has an inverse function, and then we're going to look at applying calculus. So we're going to be able to find the derivative of the inverse function. So first, let's just review the whole concept behind inverse functions in case you need a little refresher from your pre-cal or algebra class. So if you remember these symbols, well, you should know this one. F is usually going to represent your function. And then you see this f with a -1, where you're going to initially think it's an exponent. It's not f to the -1 power. This is basically the symbol that we use to write f inverse. So we're saying we have functions f and function f inverse. And an inverse function is basically a function that undoes the other function. So f and f inverse are inverse functions of each other because they undo each other. So if you were to apply this, mathematically, using composition functions, and don't worry, I'm going to review why this works. But first, let's just, let's first accept that if you take f of f inverse of x, you're going to end up with just x. And if you take f inverse of f of x, you're going to also end up with x, because they both undo each other. And you essentially want to think of, math or, algebra or calculus, whatever. We always start with, some value x. X is free to vary. X could be 1, 2, 1.5, but you start with x. Then you do something to x. Maybe it's the function. It could be multiplying, it could be adding, it could be cubing it. But then if you wanted to undo it, you would then be inverting whatever you just did. So you're going to end up where you originally started. That's why we say if you take f of f inverse or f inverse of f, you're just going to end up where you started, which is x. So let's show how this relates, with some examples, because that's, again, always the best way to really understand math. So let's say that we have some group that we're going to call this group A, and we have that f, the function f, sends all the things in A to another group B. So sends the things in A to B. That means then f inverse would send the things in B to A. But let's say that we have f of x as being equal to x plus 5. So let's say f of x equals x plus 5. And let's say A has the elements, we say things, the numbers, 1, 2, 3, 4. So what would it do to the 1, 2, 3, 4? Well, you can do this mentally. If we have 1, it's going to send 1 to 1 plus 5. So it's going to send 1 to the number 6. So we're going to get 6 in the other set if we start with 1. If we take 2 and add 5, we're going to get 7. And if we take 3, add 5, we're going to get 8. We take 4, we add 5, we're going to get 9. Right? So we go from these 4 things to these 4 things when we apply the function rule. Now, the f inverse says that you're going to undo what the original function did. So if you have f inverse, you want to figure out what undoes adding 5 to something. What undoes adding 5 to something? Well, again, this is very basic equation, so you can probably think, well, adding 5 is undone by subtracting 5. So we subtract 5 from x. Because if you add 5 to anything and then subtract 5 from that thing, you're going to end up with where you started. It's like nothing happened. So for example, if I started with f of 1, if I went from 1 and I got 6, that means if I take f inverse of 6, I should end up going back to 1. So f inverse of 6 equals 1, because again, if I just use my equation here, that means 6 minus 5 equals 1. So they're undoing each other, and you can show that, you know, we can go from 7 back to 2, because 7 minus 5 is 2, and 8 minus 5 is 3, and 9 minus 5 is 4. So what we can then show right here is just, you know, just logically, is if this is the domain of F, if this is the domain of F, A, then this is the range of F. But if this is the domain of F inverse, then this is the range of F inverse. So they basically become each other. They can basically get flipped. So let's write that down. So the domain, we can say, the domain of F is equal to, in this case, A, but that's also going to be equal to the range of F inverse. The domain of F is the range of F inverse, and the domain of F inverse is the range of F. The domain of F inverse would be this B, which is B, and that would just be the range of F. Okay, so let's go through some examples, or let's first go through one example, I guess, of how we can find the inverse, and then we're gonna go more into this because there's a lot more to it. So if you have some questions and are still wondering some things, don't worry, I'm gonna get to that. So usually you're going to see F inverse also written as, you know, just G of X, but usually in the problem, they're going to have to define it. So don't let that confuse you. Like we're going to have that notation where F inverse, remember, it looks like F to the negative 1 power as being written as G of X. And in the textbook I use and like in my notes, I'm going to be doing that a lot. So just remember that point. So again, if we take F of G of X, you'll get X. And if you take G of F of X, you'll get X, because remember, G of X is just F inverse. So again, it's not F to the negative 1 power, it's F inverse. So let's look at how we can find the inverse function. So we're told that F of X equals 2x cubed minus 1, and that G of X equals the cube root of X plus 1 over 2. But how do we show that these are inverse of each other? Well, essentially, you want to show that if you take F of G of X, you're going to get X. And if you, and you can say, if you want to prove it both ways, and if you take G of F of X, you're also going to get X. If you can show that, that's essentially showing that these two functions are inverse of each other, because they undo each other. So let's start with this one. F of G of X. So F of G of X would be, let's write the input not as G of X, but let's write the input as what the right side of the G of X equation shows, which is F of the cube root of X plus 1 over 2. Now, what is the function telling you to do for F? Well, it's telling you essentially to cube whatever this is, and then to subtract it. So what this becomes is 2 times the input which is this, but that input is being cubed. So we're going to cube this expression there, and then we're going to subtract 1 from it, just like that. And let's evaluate this and see what we get. So when you cube a cube root, they undo each other. So all we're left then is 2 times X plus 1 over 2 minus 1. Now, you can cancel these 2's. And then so all you have then is x plus 1 in this group left. And then you have that minus 1. And bang, you just get x, which is what we want. Now let's show the other way. Let's show that g of f of x is also equal to x. So we're going to have g of f of x. Let's make the inside of this be 2x cubed minus 1 then. And let's apply the g function to it. So we're going to cube and divide then whatever this is. Or more specifically, I should say, this input just replaces that x part right there. Don't put the whole thing under the root, just this. Let me use a color actually. This input goes where that x is, only that x. So then this becomes the cube root of, instead of x there, we're going to put the 2x cubed minus 1 plus 1 over 2. So this part is what I'm talking about in here. Let's simplify the inside, of course, first of the root. So we have the cube root of 2x cubed minus 1 plus 1. Those ones cancel. So you have the cube root of 2x cubed over 2. These 2's cancel. So what you have is the cube root of x cubed. And if you take the cube root of x cubed, it's just like x to the 1, or because it's x to the 3 over 3, which is just x to the 1 power, which is just x. And then that's what we got. So we just show that both of these functions are inverses of one another. Now, another thing I recommend when you are first, understanding and going over how inverse functions, work, try to actually, talk or say it verbally. Maybe you don't want to say it out loud, just you don't want to seem, weird or, like in your math class or something, but really try to maybe mentally say what this, is doing in your head. So like, let me write out what that would be like for f first. Let's put f over here. So what I mean is for f, what am I doing at x first? What I'm doing is I'm cubing x, cube x cubed, or cube x. So the first step is cube x, right? Let's say that's step 1. Step 1, I cube x. Then what do I do? Well, after I cube x, I multiply by 2. My second step is multiply by 2, multiply by 2. Then my third step, after I multiply by 2, I subtract 1. So I cube x, multiply by 2, subtract 1. Those are the steps verbally. That's literally what you're doing. Well, not literally, but verbally what you're doing, I guess I should say. Now let's write out what g of x says to do. So g of x, let's look at this. What are we doing first to that input? Here we're going from the input, we're plus 1. So step 1 is add 1 plus 1, add 1. Then after we add 1, what do we do? Well, divide by 2, divide by 2. Then after I divide by 2, I take the cube root. I take the cube root of that entire expression. Take cube root, let's say, take cube root. So I do 3 steps in each of them, and look at what's going on here. I go from cubing to multiplying by 2 to subtracting 1. From here, I go from adding 1 to dividing by 2, taking the cube root. So this kind of can show just logically what's going on when you have an inverse function, or when you invert something, or when you undo something. You don't You don't start by doing the opposite of this. You start by doing the opposite of the last step. So we go from here. What's the opposite of subtracting one? Adding one. Then we go to multiplying. What's the opposite of multiplying by 2? Dividing. Then you go to the opposite of cubing, which is cube rooting, taking the cube root. So I really advise that when you're first going over this, because then you're going to really understand intuitively like how inverse functions work, and like it's going to make your lives a whole lot easier. So I hope that helps.